Welcome to the Explainer. It's kind of funny. You spend all this time writing code in a language like Python or C++, but have you ever stopped to think about how that text on your screen actually makes your computer do anything? Well, today we're pulling back the curtain and breaking down exactly that. We're going to see how your human-readable code gets translated into a language your machine can finally understand. Let's get into it.
So let's start with the most fundamental question of all. You've got these lines of code, right? But your computer's processor, the brain of the whole operation, it doesn't speak Python. It doesn't speak C++. It speaks in ones and zeros. So how in the world do we bridge that massive communication gap?
Well, the simple answer is it needs a translator. We need some kind of special program that acts as a go-between, taking the instructions we write and converting them into something the computer can actually execute. But as you're about to find out, not all translators are created equal. In fact, they work in fundamentally different ways.
And this really gets to the heart of the problem. We humans, we operate up here, with high-level languages that are readable and abstract. But computers, they live way down in the weeds, understanding only low-level machine code, basically a really, really long string of ones and zeros. The entire job of our translator is to cross this huge divide.
First up, let's meet our first type of translator, the compiler. The best way to think about a compiler is to imagine a meticulous, old-school scholar. You hand this scholar your entire book, your whole program, and they lock themselves away. They then translate the entire thing, from the first page to the last, into a new language. You don't get to read a single word until they are completely 100% finished.
And that's pretty much the technical definition. A compiler is a program that takes your entire program and converts it into low-level machine code all at once before you ever even try to run it. It's all about doing that heavy lifting completely up front.
So let's walk through what that process actually looks like. First, you write your program. Then the compiler kicks in and basically proofreads the whole thing for any mistakes. If everything checks out, it starts the big job, translating all that source code into machine code. After that, it links all the necessary pieces together into a single runnable file, like an .exe file on Windows. And only then, after all that's done, can you actually run your program.
So why bother with all that work? Well, it has some huge upsides. For one, because all the translation is done beforehand, the final program runs incredibly fast. It's already speaking the computer's native language. It's also great for security, because you can give people the final .exe file without ever showing them your original precious source code.
Okay, now let's meet the other contender in this showdown, the interpreter. If the compiler is that meticulous scholar, the interpreter is more like a live diplomat, translating simultaneously at a global summit. They don't translate the entire speech in advance. Nope. They listen to one sentence, translate it on the spot, and then immediately move on to the next. It's all happening in real time. And that's exactly what an interpreter does. It's a program that translates and executes your code one line or one statement at a time. There's no separate translate step and then a run step. It's all happening together on the fly.
The interpreter's process is way more direct. You create your program and then, you just run it. The interpreter reads the first line, translates it, runs it. Then it moves to the second line, translates it, runs it, and so on. There's no pre-compiling, no creating a big executable file. It's just go.
And this approach has some seriously great strengths. First off, debugging is often way easier. If there's an error, the interpreter stops right on the line where the problem is and tells you exactly what went wrong. It's super helpful. Plus, it's incredibly flexible. You can change a piece of your code and instantly run it again to see the result, because there's no long, painful compilation step. That fast feedback is a game changer when you're developing something new.
All right, the introductions are over. We've met our two translators. Now, it is time for the main event, the Great Translation Showdown. Let's put them head-to-head and see who comes out on top.
Ding ding! Round 1 is all about a critical factor for performance, raw execution speed. Once the program is up and running, which one is faster?
And in this round, it's not even close. The compiler is the undisputed champion of speed. And it makes sense, right? All the hard translation work was done beforehand. The compiled code is already in the computer's native language, ready to go full throttle. The interpreter, on the other hand, is translating as it goes, and that process just naturally adds a little overhead, slowing things down.
But hey, speed isn't everything, is it? Especially when you're the one writing and fixing the code. So for round 2, let's look at what happens when things go wrong. How do our translators handle errors?
This is where their whole philosophy just diverges completely. The compiler is like a tough teacher who reads your entire essay and then hands it back with a long list of every single mistake you made. The interpreter, though, stops you at the very first error it finds and says, "Whoa, hold on. Look at this exact line right here. Something's wrong." For actually fixing bugs, that immediate specific feedback from the interpreter is often a massive win.
All right, for our final round, flexibility. Let's be honest, code is never done. You're always tweaking, changing, and improving things. So which approach makes that process easier?
And this is absolutely where the interpreter gets its revenge. With an interpreter, you change one line of code and you can instantly run it again. But with a compiler, if you change even a single character, you have to wait for the entire program to be recompiled. On a big project, that can take a long time. So for flexibility, the interpreter takes the gold, no question.
So let's just recap with the tail of the tape. What this all boils down to is that they're just optimized for different things. The compiler takes its time up front to create a standalone, super fast file that's perfect for a finished product, for your production environment. The interpreter, on the other hand, is quick to get going, flexible, and is an absolute dream for programming and development when you need to iterate and test things quickly.
Okay, so this isn't just some abstract theoretical debate. This choice between a compiler and an interpreter has a huge real-world impact on the programming languages that developers use every single day.
And you can see them right here in their corners. In the compiler's corner, you've got the heavyweights built for raw performance, languages like C, C++, and C#. And in the interpreter's corner, you have the languages famous for their flexibility and developer friendliness, like Python, Ruby, and MATLAB. Each one has chosen the right translator for the job it was designed to do.
So if there is just one thing you take away from all this, let it be this simple trade-off. Compilers translate the whole program at once to give you maximum speed at the end. Interpreters translate line by line to give you maximum flexibility while you're building. Speed versus flexibility. That's the core of the whole showdown.
And that leaves us with one last big question. As we look to the future, which will we favor? The meticulous scholar with its raw, unadulterated speed? Or the agile diplomat with its incredible flexibility? Or maybe the future isn't about choosing one over the other. Maybe it's about hybrid approaches, like the just-in-time compilation used in languages like Java, which try to give us the best of both worlds, starting out flexible like an interpreter, but then compiling the important parts on the fly for a speed boost. The translation showdown, it seems, is far from over.